Thank you. That's where I have Nolan here with me with the DC team. I have Fernando who's here
Hello.
with the Volinga team to help us kind of showcase what we are providing for the hackathon. Nolan, are you able to share your screen, my friend?
Yes, I should be able to. Let
By
me.
the way, anyone who would like to ask questions, chat is quite crowded, so please ask the questions inside the Q&A tab that you will see below the screen, okay?
Yeah,
Perfect.
great. Thank
The
you.
stage is yours.
Thank you. So, here at DC District Cinema, we're going to be covering kind of like how we have been using 3D GS in our workflows here. During production and different phases of production for film and TV. And then we're going to be talking about the Production Capture Network, which is a network of different studios that are all collaborating together to kind of provide splats and 3D GS for real-time workflows for virtual production and film and TV. And that's kind of like what we'll be covering today. Next slide, please, Nolan.
Mhm.
Sweet. So here at DC, at District Cinema, our mission is to simply empower production at different phases um, throughout the entire workflow. We go from pre-production all the way until final pixel, and we try to show these productions how we can start utilizing reality captures, Gaussian splat scans for things like location scans and scouting, for previs and planning how to do your shots and actor blocking to some form of relighting workflows and essentially preparation for on-set production. And then when you're on set, how can these splats be useful for transitioning from the planning phase to the actual execution phase? And then when you're on set, how can all that type of work get saved and get sent over to the VFX workflow for Final Pixel and things like that? That's where overall we have a different range of services and workflows that we kind of implement into productions to kind of help amplify these productions. Our main goal is to just help simplify workflows to kind of create efficient steps throughout the process, but also then empower each department so that they feel that they are best prepared for the shot that needs to happen at that exact moment. Next slide. And that's
Yeah,
where
so I can sort of talk about this. My name is Nolan Carney. I'm the technical director over at District Cinema. You can see some of the videos on the side, as sort of Renee touched upon a little bit. It's sort of been happening over the last couple of years, where a lot of the reality capture stuff went from sort of a luxury for film production to a necessity. It's there's no None of us are under any assumptions. The film industry is contracting. That's just a statement of fact. It has been in the last couple of years, especially in the LA area. And a lot of these ways for doing quicker reality capture that's more efficient, saves money and time, both for on-set production and then also for LED wall and all the virtual production, which is something that thankfully we've been partnering with Volinga to make that happen, which we'll go into later. It's sort of become a backbone to be able to get the data acquisition at the start. So if anything happens, if reshoots need to happen, if you need to move over to an LED wall for any reason, if you need to redo your planning, if you can't send specific team members out, the whole, and everyone's sort of heard the spiel at this point. If you're on LinkedIn, the 3D Just community in any sense is sort of this has become a necessity. So a lot of the stuff that we do, we use a lot of either custom built rigs with 360 cameras and DSLRs, or we just rely on the X-Grids portal cam and then the K2, which is sort of become industry standard at this point for a lot of the reality capture. You can see these are some quick scans that we did on the right here. These are an abandoned theater, a palace, and then the exterior of the palace over in Hungary. These took about under an hour probably, and you can see the quality of these is pretty great. This is one guy walking around for 45 minutes. This is also with the new, being able to use Volinga and having it do an ACES color pipeline workflow and making sure, we put color checkers in all of our scans and make sure that happens. This is kind of a necessity on the capture side. And then again, if you're using X grids, you can do centimeter level accuracy, which sort of starts to become, and we'll get into it in the next couple slides, not only is it you're capturing the actual physical space itself and then the actual space for filming, but you also giving yourself a ground truth and a 3D representation that can be used for these AI workflows. Obviously, if you give an AI model an actual ground truth and 3DGS or point cloud data to work off of, and it actually has that space to work in, we've seen the results exponentially get better, especially when using something. One of our partners is Beeble, especially when using something like Beeble with their canvas feature or Switchlight or SwitchX. It's really, really drastic. Go to the next one. Cool. Yeah. So you can see a couple of examples here. This is for when we're doing pre-production. How we started with this was we basically just wanted to be on sets more, doing quicker scans. So we're like, how do we get on sets, do quicker scans? So the decision was pre-production. You can see this is a demo we did at NAB this year. This is with markerless motion capture, all put in the scans. We've synced up. We have using Claude coding is really saving my ass with the amount of awesome stuff I can do with it. So building Unreal plugins so it perfectly syncs the iPad VCam that you get out of Unreal with any markerless motion capture data that you can get in from Capture, from everything else. So you have that, so you can see here, you can get real camera position without having to put a whole camera tracker on your iPad. You can start to frame up shots. You can have it relative to each other, which is, a game changer for previs. When you're doing something in the Unreal side of the world, especially when it can be live, and you can see you can see one of our stunt coordinators, Millie, here doing as little alien, and this is in one of those scans again. This is all in the scan. So this is, as it says in the slides, not to do death by PowerPoint. You can do virtual lenses, frame shots, sun path. A lot of these now, if you know what you're doing, you can also bake out a really good mesh, sometimes even better than photogrammetry, because you can rely on the spherical harmonics to get bits of glass and mirror that you wouldn't have been able to get in a traditional photogrammetry pipeline. You can bake that out and then use that for shadow passes. You can bring it into Volinga and use that as the proxy mesh that it does the normal estimation on, and then you get great relighting features, which is obviously something that's still somewhat, pending the AI transition, somewhat of an issue with traditional 3DGS and captures. Okay, so then you can get into the actual visualization. So this is sort of the next step. Once you do your location scout, okay, actor A is going to stand here, actor B is going to stand here. We're going to look at each other. Oh crap, I can't be, the camera's bumping into a wall. I need to go on a wider lens, or let's reorientate ourselves. You actually get into the previs part of stuff. This is where your generative AI workflow comes in. You can see here, this is an actual scan that we had done over in Italy, I believe. This is Conrad in the scan. We masked him and then put him and the scan through. This is very, very early SwitchX. If anyone has used SwitchX by Beeple, I think this might have even been the beta version. But just had it comp together the camera track from the camera and then the actual scan, and we were able to send this off and start to get pre-production and some animatics and previs for what we wanted to do for the shots and the shot composition. This is also true if you don't have the scans, if you want to just use a general environment and give it that grounding. This is some previs that some of the stunt coordinators do. You can see them switching through. Now you notice it's not, I'm under no assumptions, it's not entirely perfect. You can see the knife do a bit, obviously it's a foam knife, but in addition to that, AI has trouble realizing that. So there's some errors there. But if you're doing a previs workflow and trying to hand off to client and get an idea, that's fantastic. You can see exactly what the sort of relative scene will look like. And then when you're doing your blocking, that has a huge effect on what you're going to do. And then this is actually with in Unreal. This is like the full drop in equipment, get an idea of where the set is. And this would be for like, your location scouts, your production coordinators, all that, when they're actually, wow, that is repeating quickly, when they're actually getting an idea of the physical location. Let me switch through. Okay, yeah. So then this is sort of in terms of the hackathon and in terms of stuff you can do, combining 3DGS, camera tracking, Unreal with the Volinga plugin, and then also whatever generative AI you want to put on top of it. This is sort of that natural progression. This is something that me and Renee, I think literally while no one was paying attention to us one day, and we didn't have anything on our plates, shot this by ourselves. This is essentially we're in our similar location. We're in the blue box. We're recording me walking through. We're taking in. I think Renee, correct me if I'm wrong. I think we actually didn't even use Capture or any motion capture this one. This is, I believe, Depth Anything 3 using the depth pass and then giving myself relative occlusion so it's spatially aware, and then just walking around and then getting this is all live. This was a live comp in Unreal, and then doing the Switch X pass on top of it. We did a bunch of styles of this to try to merge those together. This maybe took us after we
I
built the
think it was like a
plugin.
30 minutes. Yeah.
Yeah, I think after we built the plugin and then after we ran a couple different SwitchX models and decided how we wanted to do the Depth Anything 3 into SwitchX, or this would have been Depth Anything 2. Yeah, 30 minutes from hitting record to getting these plates and some other ones. We did snow, we did sort of we did sort of a cyberpunk one that looked freaky. But yeah, and then this can go for again combining it with the motion capture that you saw earlier if you're able to take in that data. Obviously there are so many amazing AI motion capture softwares now. We're using a full system for this, but Unreal 5.8 has their own video to motion capture. There are ones that, there's a lot of ones in Blender. There's honestly too many to count for being able to ingest video and then bake out within a matter of minutes a full rigged character. So this is something that you can do and then build that into your plugin or pipeline for the hackathon where it's like, okay, you take in my video, track the person, give them a full metahuman model on top of them to get them stylized. You can see me in the night here, put them in that 3D GS, then start to restyle, then start to generate. Obviously, we're doing basic lighting stuff because that's what the creative wanted for this exact pass. But this could be something where you could generate whole new, models, environments, and merge the two together, have that as its own pipeline. And then, yeah, then this is the final pixel quality. Admittedly, just due to the nature of where the studios are now, not a lot of this runs with generative AI. This is more just straight 3D GS into Volinga. These are captures that we've done for Roosters, Rooster, the HBO show with Steve Carell, and for Shrinking. So you can see this is probably about an hour and 15. Oops. This is probably about an hour and 15 minutes work for me, going through the office, scanning, doing HD enhancements, knowing where I need to post-process, and then merging the post-processed photos and merge them in with the XGrids data wherever I thought that it wasn't perfect. And then, yeah, this is something that they can use for either reshoots, if they want to recomp anything, if when they do another season. I know for this, they actually had to break down all the sets for that show, which had just amazing sets. The craftsmanship on that was insane. So this is obviously a point of reference where I can go, okay, we see exactly where everything needs to go, and we have a perfect 3D visualization of that. So that's something it's actively and currently being used now in the film world, just because it's such an easy use. Everybody has to, at this point, most of the Apple TV shows are going to get another season. It's sort of guaranteed. And will have to rebuild sets or change sets. So having this ground truth data is incredibly helpful. And then same for this is side note, but this was by far probably my favorite set in years that I've been on. But this was fully built out, multi-story, fire lane to fire lane set for Roosters. That again, we scanned this. This one was massive. Took a little longer. This was a couple hours, but the whole entire student college exists, and this is all on a soundstage over in Warner Brothers. And then I'll kick over to Renee.
Sweet. Thanks, Nolan. Yeah, so as you guys see that there's been a bunch of different utilizations of Gaussian splats and how we can start throwing in different forms of like AI models to markerless mocap to different pipelines, and then taking it to like how can it be production ready and like what is it being utilized here on production, right? So on the left, you'll see that this is going to be filmed on the MGM stage in Amazon Stage 15 here in LA. That's on an LED wall. This was us doing a test to see whether or not the Gaussian splats would hold up performance on a massive volume where they filmed a bunch of different Amazon Prime shows. And then on the right side, it's in our blue screen stage up in Silmar. And that's where the main thing that you're seeing with both of them is that it doesn't matter whether you are production high quality at Amazon on an LED wall, or if you're whether you have a blue screen stage or if you only have a blue screen, screen just behind you. That's where the what we're starting to identify is that these workflows are able to kind of start producing similar results depending on what the need and the ask is from the production. We're able to scan a location and then deliver it to the client to their stage within a week, give or take. And that's where, with some cleanup of whatever excess, like particulates and like extra Gaussian splat noise that is like still in existing. We clean that out and we're able to deliver that to the client, and the client's able to start planning their film, their shots, the acting blocking, how to maybe start relighting things. This is all to help them prepare for the actual production, and or if this is a workflow that they want to dive into, like film on an LED stage or a blue screen stage, this kind of gives them that type of ballpark. If they are scanning a location, planning out everything in a safe environment in Hollywood, and then once they feel comfortable and ready, get flown out to that practical set and then start actually filming things there. The entire crew and the cast start to feel very comfortable in those locations because they feel like they have been there the entire time. Um, all these things are supposed to kind of help out with the sustainability and the green energy that we're trying to lean into, and that's where it kind of kicks off to the next slide that Nolan can to talk a little bit more about that.
Yeah, so a lot of one of the things that we're doing at DC, which one of our producers has kind of been spearheading, is trying to lean into the fact that if you're able to do location scans, and I know this is something that Warner Brothers and Netflix have done as well, if you're able to do location scans of especially like hard to reach places outside of the country and bring them back and not have to fly everybody over, not have to fly your gaffer, your DP, your production coordinator, everybody to the location to do a scan for both the like air travel, but also we've worked on shows where they're shooting in the US and they have a 1 week break and then they go shoot uh, in Europe and they don't have time to do the in between. They'd have to be doing back and forth flights while in actual production. So one of the efficiency things is one, money, which is just it will save money, but two, also go to the next one, is also part of just a green initiative to be, hey, if we don't have to fly everybody out, hell, if we don't have to drive everybody out, we're saving time, we're saving energy, we're making it more cost efficient. We can do planning in LA and send it elsewhere with tax credits and benefits for the fact that it's being efficient that exists. I know that London has really, really great tax benefits there. America also has some tax benefits. Italy as well has tax benefits and credits if you want to do it in a more sustainable fashion. And in at least in America and in London, the doing the location scouts and doing the location scans are accredited versions of that. And that's something that you can use to actually make your production more green and energy efficient, in addition to getting a tax write-off.
Cool. So last bit here before we hand it over to Valinga, that's where now with all of this, we created the production capture network. This is a network over a couple of studios throughout the entire world where we are all working together so that we can help productions be able to efficiently plan their shoots, whether it's in Americas, whether it's in Asia, Australia, South America, etc. We really tried our best to kind of have coverage throughout the world, and that's where for this hackathon we are providing a sample project of a couple of locations that have been prepared by the Volinga team, and that's where these scenes will be ready for you guys in an Unreal project for you guys to kind of utilize and hopefully plan your mini film here. And that's where to kind of hand it over to Fernando from Verlinga. He can talk more about the project itself and answer your questions.
Thank you very much, Rene. So let me share my screen real quick, just to make sure you can see all of that. So yeah, well, going into what's Volinga, but we'll probably focus here on the Unreal side of things. But at Volinga, we try to provide tools for professionals to create 3D Gaussian splatting. So what you're seeing right now is Volinga Suite, which is what the tool we provide for the creation and authoring of Gaussian Splats, and this is already a plugin. So we have these two pieces of software, the one for the creation, let's say, and the authoring from images or from videos, and the other one for properly using that on Unreal in video production workflows, but not only. You can also use this on video games, architecture, etc. So we'll be focusing today on the Unreal Engine plugin because, as Rene said, you will be provided an Unreal Engine project that has some amazing capture from the production capture network, but also you can also combine this. You can also combine our plugin with World Labs captures, with World Labs, assets. So essentially, what you will need in order to run the project, or in order to run our plugin and use World Labs models, is the Unreal Engine from version 5.4 to 5.7, which are currently supported by the plugin. This will be probably provided with the Production Capture Network sample project. Actually, will be provided. Then the Volinga plugin version 0.9, because the hackers, you will be using a floating license, an online license during the hackathon, and that's the plugin supporting that specific license. And then you will need one or more 3GS models, of course, provided by the Production Capture Network, but you can always generate your, more models using World Labs in order to run this on Unreal Engine. So it's very easy to start. Before going to how to actually start this, I also recommend visiting our or documentation page. I have a QR code at the end of the presentation, so you can go and check that. But everything that I'm going to explain here is very well explained here. So if you have doubts during the hackathon on how to do something, you can always refer to this website. Also, a special mention on product overview on the Volinga plugin. This video explains everything end to end, and probably is going to do that better than I do. Nevertheless, the first thing is to install the plugin on the project. If you're using a Production Capture Network project, the plugin will be already installed. If you are running from a blank project and using World Labs models, you will need to install it. It's important to take into account that we have two plugins that act as only one, but take into account that you will need to install both of them. Once that's installed, and this is again before actually working with the plugin, but these are let's say the common pitfall when getting started, you will need to log in the plugin with a floating license. So I just have this video that will explain. Oh, hopefully it loads. Apologies for my internet connection. Let me try it again. Okay, so otherwise I will show you in the documentation if this does not load. Okay, so while this loads, you can find how to run how licensing works here on all documentation, and it's very important, or even easier on tutorials, you can go to floating license. It's actually the first one. Maybe here we have more like here. Yeah, so this works better. This is the same video, but essentially it's very simple. You will just go through these three dots that you have here. This the Volinga. We will talk about this later, but this is the Volinga menu of a plugin, and you will see that here on the license panel you have different options. Use the login one. These are essentially for offline licenses. You will be using this one, and the organization will provide you with the credentials you need to use in order to log in. Once that's done, you will be able to use the plugin. I would say that 50% of the time, people mess it with the licenses, and that's why they don't see the Gaussian Splats on our plugin. So if you will, for example, load a new Gaussian Splat into your project and you are not seeing it, check out if you have logged into the plugin. Let's see if now this is working. Let's go to the next one. So yeah, now let's go for this. Yeah, this is working now. Let me show you the plugin itself. So this video walks you through let me do a try 1.5 because it's actually quite long. Once you know how to create a project or a level with Volinga plugin, we usually recommend being a little bit organized and having different folders for different environments. Here we are just setting up everything just to create some environments, sky, environment light, fox, make it more cinematographic. But yeah, let's go here. You will see again. These are the Gaussian Splats models that you have available. In order to get one of these, once you have to plugin install, is as easy as drag and drop it. Just drag and drop your Gaussian Splat model in the content browser. And then once they are in the content browser, you can drop it on the viewport, and you will see the splat. Right now, sometimes you get just splat rotated, or you can adjust it as you will do with any other Unreal Engine asset. And here, what we are doing is adding a Volinga mesh actor. This is not needed, but recommended, especially if you are using wall labs models, you get this for free. So in order to relight, we have different ways of doing the relighting. Your Gaussian splats I will show you how to make them actually interactive with light, but they will be by default interactive with light using normal estimation method. By using Volinga mesh, we use this proxy mesh in order to have better normal estimation, but also better self shadows and shadow casting from the splat model that is not available if you are not using a proxy mesh. And also you can do more advanced things like material editing, etc. So essentially here, what you will need to do is align this Volinga mesh model with the Gaussian splat model. In this case, this was coming from SGrid. That actually it was an SGrid scan, but also this, as again, in wall labs, you can do that, the same thing. It's very important to disable nanite if you want to run with, for the meshes, if you want to run with Volinga mesh. And yeah, let me go back here because this is important. It was fast, but this is important. This is the menu. So in order to enable and disable the light interactivity, this blue button is your key. By clicking it, it will enable or disable, it will toggle essentially the light interactivity. Then you have these estimated normal methods and these proxy-mesh-based normals. These are the ones that are on by default, and you don't need a proxy mesh in order to run them. Your Gaussian splat will react to light as any other asset, but without self-shadows and without casting shadow themselves in other elements. And with proxy mesh, you will need a proxy mesh as we are setting it here, but you will have better light, better interactivity, and better shadows. The ambient light is the amount of light the Gaussian splat is emitting. So if you set that to 0, you will need to add light in order for the Gaussian splat to be visible. If you set that to 1, the Gaussian splat will emit light. It actually won't be casted or won't be emitted into other elements, but it's just that you won't need any light to actually add it. You can play with everything in the middle. And there are a couple of more parameters that are specified in our documentation, but these, which is the light parameters, are the most important one. So yeah, as you can see, once we change from estimated normal into proxy mesh, the proxy mesh disappear. It's just blended into the Gaussian splat. And now we will be able, you can see now we make this Gaussian splat, it should be darker. Oh yeah, here there is a small trick on how to actually make the shadows more sharp, but this is more on the static mesh side of things. And there you go. You can see now that how the Gaussian splat is casting shadows. And there you go. So once you have all of this set up, actually you can play with this as any other Gaussian splat environment. Oh, sorry, as any other Unreal Engine environment. You can place your lights, you can change the color, you can place any other 3D elements. Actually, here we are just showing how to place more and more lights. You can use any lights. You can place CG assets that you can create using any GenAI tool or 3D assets you have from other projects, etc. So you can dress your scene. And once that's ready, you can actually have, yeah. So yeah, we usually, before I forgot, we usually recommend adding a post-processing volume with these specific settings in order to make everything looks better. And usually on the Unreal Engine, let's say, mess it a little bit with the Gaussian splat results, or with Gaussian splat look. So yeah, usually adding this kind of post-process volume make it look much better. And yeah, essentially you can dress it and build your scene and do and work with all the pipelines that Rene and Laurent has previously presented, but with a special control on Real Engine. And final thing that I also recommend looking in for the webinar, let me just, there we go, is this video actually, which is from World Labs, that explain how to go from World Labs into this same thing that we have just done with Volinga, but it also shows you the actual exporting way. And all of this can be actually scanned here. So this is the World Labs video, this is a Wikidocs, and this is our LinkedIn, because Volinga, we are very happy to participate and to support this hackathon. So we will be very happy if you are able to share your results in socials. We will repost them, and of course, we are looking forward to seeing what you create and what all these really creative hackers are able to create with Volinga. So yeah, that was all from our side.
Yeah, and one last quick thing that I'll just cover for a moment, just because I saw some of the Q&As pop up about like time for processing, what the workflow is for this. Obviously, for the sake of what we were doing in the film and TV side of the world, we're doing stuff with like real scans, but World Labs is part of this hackathon, and you'll have World Labs. And I'll show an example here. Let me just share. So it's a generative Gaussian splat builder. So we are going to share Marble. So yeah, you can see this here. Let me hide that. So this is literally like a pano that's generated. Then okay, make some changes because I didn't like that, and then just go straight into being able to generate it. Obviously, it will take a couple minutes, but it's very, very quick, and you can generate a full 3D Gaussian splat world environment based on image inputs and then panos, and then bake that out. So this is something so that you can get the grounding data and the 3D model from the Gaussian splat, but not have it be, because realistically, you're right. I think someone's question was, what's the processing time? The processing time for some of the larger XGrid scans can get up to like 12 to 16 hours for the larger ones. For the smaller ones, it's only like a couple hours. But for World Labs, it's much, much quicker. You could do multiple photo inputs. So I could just walk around my house, take 8 photos, it stitches them together, bakes out the pano, and then gives me a result in World Labs.
Thank you. Sweet. Farhan, I think we are good, or Laura, I think we're good now for Q&A.
Yeah, we have 2 questions. One is, what's the workflow of this word hack? Is there a framework that enables existing dashboard to drag and drop into runway interface type thing available for this? Probably for the hack. The second one, are ceiling heights still a constraint in these real-time hybrid filmmaking solutions? For example, is the gray box solution more about the horizontal white space now, and are lower ceilings a constraint?
I'll answer the first one first. Yeah, so there's less of a specific dashboard. There's sort of a couple. There's you obviously are going to have the splats provided to you by the hackathon team for the existing ones that exist in the production capture network, and then you can bring those into Unreal, and you can relight, you can do renders, you can bake everything out, and then use that as part of your generative workflow if you want to kick that into something else. Part 2 of that is sort of the World Labs. That would be the closest thing I'd say to like an existing drag and drop dashboard, is if you want to do generative images or your own images, put them through the World Labs dashboard. I can even pull that up just so you have a better idea, picture 1,000 words and whatnot. Let me share my screen. Yeah, so in Marble, you can see I've been doing a bunch of just random testing, but yeah, you can see you can generate an image. I generated an image with Gemini, and then built out a world, and it's really that simple. It's as simple as I could say, imagine a world, chocolate house, and then my God, I misspelled chocolate. And then add photos of that. You can also do a 3D input, which is really fantastic. I really love this feature, and actually do basically gray box your entire world setting, and then be able to generate on top of that, so you have way more control, and it has that net underneath it. So that's sort of to sort of get to your question, is that's sort of the closest thing to a singular hub for a lot of this 3D generation. That's how you get stuff like this and going forward. It's not perfect. You can see the text, but it's a great grounding for any other workflows you want to do on top of it, or use it for if you want to do like a full filmmaking workflow. The fact that you can like immediately have environments, start doing comping, start generating your motion capture data, putting it on rig characters that you generate. That's sort of the kind of stack that you could utilize for that. And then to your other question, are ceiling heights still constrained in these real-time hybrid filmmaking solutions? I assume, and apologies just for clarification, I assume you mean ceiling heights of the, like you built like for like gray box stage or the blue box stage. I assume you mean that for like ceiling heights in space for that solution. Yeah, perfect. Not really, or at least nothing that I've run into. For the comping that we're doing, let me just make sure I understand the question before I give an answer and shoot from the hip. Yeah, a lot of the comping. So we use a lot of Unreal Engine, and we benefit from Composure, which is the 5.7 and 5. They had a pre 5.7 and 5.8, but 5.7 and 5.8 have an updated version of Composure that lets you put in a quick like photogrammetry scan of your actual space, or even a gray box of your space. So when it's projecting whether that be with blue screen, or if you want to do like an AI roto in depth workflow that we do, it's projecting that onto the existing space and taking the existing space into account. So that means that we haven't really run into that constraint at all. I would imagine if I was like maybe in my living room and wanted to do like a LeBron style leap straight up into the air, you might have a couple issues. But for most of the workflows, no. If that answered your question, and feel free to follow up if that was a little vague.